Now in the earlier lecture, we already learned that what exactly are the importance level for various kind of buildings in, we can say, Australia. So this was a snapshot of the National Construction Code of Australia. So as per the importance level, we can easily determine the annual probability of exceedance for non-cyclonic, cyclonic, and snow and earthquake. Now in this lecture, we shall learn about the section 3 of AS 1170. Now section 3 of AS 1170 dot 0, that basically it also deals with the annual probability of exceedance for structures in New Zealand only. So for structures in Australia, we have to refer to the National Construction Code, but for structures in New Zealand, we have to refer to the, we can say, section 3 of AS 1170. So this section basically deals with determination of annual probability of exceedance for ultimate limit state loads for New Zealand. And the maximum importance level that is given is basically importance level 4. Now there is this importance level 5 also, and that is beyond the scope of this standard, and we do need to determine the special studies for that. So I repeat, for buildings within the Australia, we need to refer to the National Construction Code of Australia. For buildings in New Zealand, we have to refer to the section 3 of AS 1170. Now when we have to shortlist the design requirements. Now building may be constructed in such a way that during its design working life, with appropriate degrees of reliability, it can sustain all the actions and environmental influences that's likely to occur in its life. Now our main target is that for earthquake action, it should not collapse, and it's the non-structural elements such as we can say the windows, or we can say the glass, that shall also not collapse, and to perform adequately under all expected actions. So the purpose of importance level is that not all the buildings are same. Some of the buildings can sustain some higher damage as compared to the other buildings, but the main purpose is that, like for lifeline structure of a very critically important structures, the building should be intact, and they should be such that they can be immediately occupied after a major extreme wind or after a major extreme earthquake. So we cannot go on constructing all the buildings with very high importance level, because that shall eventually lead to rise in, we can say, cost of housing also, and that shall eventually lead to an very high economic cost also for the country. So that is why we have to divide the occupancy divide the importance level of the buildings. Now, as a simple thumb rule, if we are talking about the building having medical emergency or surgical facilities, that should not be designed for the same load as we are designing the car parking building, because car parking building may sustain minor damage also, or without obviously any loss of life. But medical emergency surgical facility, that should be designed with the highest importance level, because that is a very important building or a structure. So now when we are dealing with the buildings in New Zealand, for importance level 1, more or less it is same, that structure with total floor area of less than 30 meters square, and farm building, isolated structures, towers in rural situation, fences, mast, walls, and in-ground swimming pools. So all of these structures have to be designed with the importance level 1. After that, importance level 2 has to be the, we can say, single family residential buildings or car parking buildings. Importance level 3 are those structures that may contain people in crowds, or content of high value to the community, or pose risk to the people in the crowds. What are the example are the primary school, daycare facilities, and we can say college or adult education facilities, healthcare facilities, airport terminals, correctional institutions such as jails, and multi-occupancy residential, commercial, industrial, and office and retailing building designed to accommodate more than 5,000 people. After a public assembly building, all of these buildings are importance level 3. And importance level 4 are basically, we can say, the buildings and facilities designed as essential facilities, such as medical emergency, building and facility with special post-disaster functions such as cyclonic shelters or emergency shelters. After that, emergency service facilities such as fire, police station, and emergency vehicle garages. Designated emergency shelter, or we can say emergency centers also. And after that, building and facilities containing hazardous material capable of causing hazardous condition that extend beyond the property boundaries, such as a building storing, we can say, flammable materials, or a very flammable chemical that may extend beyond the property line in case there is a fire, or in case there is a damage due to the earthquake. So that for those buildings, that needs to be in importance level 4. Now similarly, when we have studied about the annual probability of accidents for Australia, the table was a little bit different. The table was a little bit different, that we were talking about simply the importance level and simply the annual probability of accidents for non-cyclonic, cyclonic, snow and earthquake. But when we are dealing with buildings in New Zealand or structures in New Zealand, we are dealing with this table here. So not only this code is guiding regarding the design working life also, and it is also giving us various different numbers. So simply when we're talking about the construction equipment, that is props or scaffolding, in that case we don't need to design it for a very high wind or snow or earthquake. We just have to take the annual probability of exceedance as 100 years for wind and earthquake, and for 50 years for snow, and for serviceability limits it as 25. Now the difference here is also that when we are talking about the annual probability of exceedance serviceability in limit state, it is a serviceability limit state level 1 and serviceability limit state level 2. Level 2 we shall talk when only for the importance level 4 building. So when the building is importance level 4, we are talking about the serviceability limit state level 2 also. So after that, we are clear about the construction equipment, props, scaffolding, beams. Less than 6 months maybe structures which are required to be constructed for, we can say, small amount of time. But in reality we don't get these 3 cases much. We only target these 50 years or 100 years when we're talking about the major buildings and major structures. So for 50 years, let us suppose we are talking about the level 4, importance level 4. We are talking about the wind as 2500 years, we are talking about the snow as 500 years, and we are talking about the earthquake as 2500 years. And serviceability limit status 1 upon 25, and importance level 2, service level 2, we are talking about 1 upon 500. So even if we are at a very lower level here, but for importance level 4 we are targeting 1 upon 500, and that is also again quite high. So if we compare like importance level 4 with the, we can say, the building code of Australia, it was building code of Australia, but now it is national construction code. So importance level 4, in here we are talking about the this particular table, and in here it is for wind it is 2000, and for earthquake it is 1500. So in here you can see that for wind it was 2500, 500 years more, and for earthquake it was 1500 for we can say Australia, but it is 2500 for earthquake, because again we can see that the buildings and structures are much more, we can say, prone to damage when we, because in New Zealand the earthquake is also very high, and it is also subjected to cyclonic winds also. So that is why the structures in New Zealand are, we can say, much more expensive also to construct as compared to structures in Australia. So that was the basic science, we can say. When we are dealing with much more, we can say, higher earthquake and higher wind forces, we have to take much more factor of safety as compared to Australia, where we are dealing with not that high earthquake and not that high winds. So as I said that in the earlier lecture also, that structures in or structural engineering in New Zealand is much more confined to earthquake engineering, but structural engineering in Australia is much more confined to wind engineering. So that is the, we can say, major difference between the structural engineering conceptual approach in both the countries. So I hope the table is now clear to you, and that was a simple introduction to the selection of the importance level and annual probability of exceedance, and this lecture basically forms the foundation for all the other lectures that we shall be studying, because annual probability of exceedance is a concept that must be clear to you. If we are talking about the number that is 1 upon 500, so there is a 1 in 500 probability that it may get exceeded. Like if we are talking about the snow load, so there is this probability that 1 in 500 cases it may get exceeded. Similarly, for earthquake load, for 50-year return period, there is this probability that 1 in 2500 years the earthquake load that is considered, it may get exceeded. So that is the basic concept.